Hi friends, welcome to the lecture on power plant economics. Hope you are enjoying the corona break. This video has been prepared to trouble you a bit in this holidays which you are enjoying. This is a video on power plant economics. The outcome of this lecture or a video would be that you would be able to calculate the cost of generating 1 unit of electricity. This is an introductory lecture. It will equip you with the tools, the parameters, the terms which are used in the everyday economics of power plant. So I hope that you would enjoy this small video. The key concepts which we would be learning in this course would be to understand the terms like capital cost, the running cost, and the cost per unit of electricity generated. Capital cost is basically, in the layman's language, it is basically the investment which goes into the power plant. So obviously you must have seen the huge structures, namely the power plants, during your visits to different units at Eklare, for example. The huge investments are being made there, whether it is a coal-based power plant, nuclear power plant, hydroelectric power plants. Huge investment goes into it. So that would influence the cost of generating electricity. Obviously, this cost typically would vary between 4 to 6 crores depending upon the technology which we are harnessing. And because the investment is so huge, 4 to 6 crores per megawatt. So you understand. So you can just calculate. You can do the back of envelope calculations for us, let us say a 200 megawatt power plant. So 200 into 5, you can imagine the number. So that capital cost which is being invested would influence ultimately the cost of electricity which we purchase as a consumer at our homes. So that is called as a capital cost. This capital cost would contribute to the fixed component, or is also called as a fixed cost, in your energy bill. The second component is the running cost. It is also known as variable cost. And as the name goes, it's variable in the sense that it would change depending upon the number of hours the plant is in operation. What is this running cost about? So to run a power plant, typically a fossil fuel power plant, we need to burn the fuel. A coal-based power plant, we need to burn the coal. So the number of hours we use the power plant, more would be the consumption of the coal. Similarly, for operating the power plant, we need to employ people like you and me as engineers, employ skilled man force, employ the people in the ad hoc manner also for loading and unloading operations, for minor maintenance kind of things. So there are huge requirements for manpower in power plants, especially the fossil fuel power plants. So that would contribute to the running cost. If the plant is shut down, obviously you won't require fuel, you won't require the manpower to handle it. So the running cost would be a function of the operating hours. It would depend also on the type of the plant. If it is a coal-based power plant, it would have a different running cost. If it is a hydroelectric power plant, it would have a different running cost. If it is an old plant, so it also depends on the age of the plant. If it is an old technology, old plant, the running cost would be different. Why? Obviously because the efficiency of the older plants would be, generally speaking, lower. If the efficiency is lower, the fuel consumption would be more. So the age of the power plant would have an impact on the running cost. The technology which we are harnessing, that would have and influence on the running cost. If it is a supercritical boiler technology, if we are using, for example, or if we are using a fluidized bed combustion boilers, that would be more efficient, for example, as compared to the low pressure or drum type boilers. So the technology which one harnesses would have an impact on the running cost. And they together means the fixed component and the running component, they would together contribute to the total cost. So we add up the total cost and divide it by the total number of units. Units means what? Units means the kilowatt hours of electricity which is being generated by the plant. If we divide it by that, that would be, what would be the unit for that? Cost unit is rupees, and the total units would go by kilowatt hours. So it would be rupees per kilowatt hour. Kilowatt hour, generally people would understand not as kilowatt hour, but they would say 1 unit of electricity. So cost in rupees per unit of electricity generated, that ultimately is the output of the economic calculations which we do for a power plant. It could be expressed in different other ways also, like calculating a simple payback period or internal rate of return of investment and all those things, but that we are not going to deal in this video. So as I said earlier, how much investment goes into a power plant? So this is a thumb rule, and obviously it is not a fixed kind of thing. It would change with respect to the technology. It would change with respect to the value of uh, the exchange rate, for example, because many of the equipments are imported. So this is not to be just used uh, every time at this number 4 to 6 crores. I generally given you this range, but to do a back of envelope calculations, you can make an assumption of a capital cost of let us say 6 crores for every megawatt of installed capacity. And you know 1 megawatt is 1000 kilowatts. And a typical size of the power plant, let us say a coal-based unit, which we have seen, one unit would be approximately 200 megawatt. It could also come in the units of 500 megawatts or 1000 megawatts. The scale, it is called in economics, we use a term called as economics of scale. As we build huge capacity power plants, the cost, the fixed cost component is reduced. The capital cost is reduced. Obviously, if you are constructing, let us say, a 10 megawatt coal-based power plant and a 100 megawatt 10 coal-based power plant, then it does not mean that a 100 megawatt coal-based power plant is 10 times costlier than the 10 megawatt coal-based power plant. So why is that so? It's called as economics of scale. So as you scale up the power plant, the capital cost would reduce. So the typical capital cost, which I am saying, which is 4 to 6 crores per megawatt, this is for the unit size of 200 megawatt and above. If you plan to construct a smaller coal-based power plant, for example, if you design a 1 megawatt coal-based power plant, it would cost you around 8 crores per megawatt. This has to be kept in mind when we talk about the investment or capital cost. So as I said earlier, capital cost is an investment, right? And this capital cost would decide what is the contribution of the fixed cost in your energy bill, right? So how am I differentiating between the capital cost and fixed cost? So capital cost is the investment which you are making when you set up a power plant, and fixed cost is the cost, annualized cost, that is the cost per year by virtue of the capital which is being invested, right? Now to understand this more clearly, if I say that I am investing let's go to the next video to understand this. Let us say that I'm investing 6 crores per megawatt. So 6 crores per megawatt is not the fixed cost. Okay. uh, 6 crores per megawatt is the capital invested. So what is the fixed cost to it? So it would depend upon the rate of interest, rate of borrowing that money. Obviously, when you are making an investment, even if when the government is making an investment, that investment has to come from somewhere. Somewhere means what? For example, if a government is making investment, it might take a loan from World Bank, okay, or it might take a loan from some international bank, or it might have its own resources also, whatever, but that would have certain rate of interest, right? So let us say that the rate of interest is 10%. So the 10% of 6 crores per megawatt is 60 lakhs per megawatt. So the fixed cost is 60 lakhs per megawatt, assuming a rate of interest of 10%, and the capital cost is 6 crores. So you need to be very careful in differentiating between these two. So fixed cost is by the virtue of the interest rate or also depreciation. So let us say 5% is a depreciation, 5% is the rate of interest, 5 plus 5 is 10. So 10% of 6 crores per megawatt, that which is 60 lakhs per megawatt, is the fixed cost. It is not the capital. Capital cost is 60 lakhs and the fixed cost is 6 crores and the fixed cost is 60 lakhs per megawatt. This has to be clearly understood. And this fixed cost would also depend upon, so the cost of capital means interest rate, and the fixed cost would also depend upon the operating hours. So this has to be clearly understood what I'm saying by this. So to take an example of uh, a taxi, for example, if I'm having, if I'm buying a taxi